Okay, so let's get into the AWS and global infrastructure. So, traditional enterprise networks are complex. So, now today you probably have multiple sites, not just your data centers, you have your branch offices and you have all your other areas. And yes, it is a hybrid world. So basically a lot of companies, they do want to move into the cloud, but essentially some applications or some, things still require data center connectivity. I know essentially when I first worked on that first project with AWS, with Amazon Robotics establishing connectivity, it just couldn't work because of the latency and the jitter based on controlling the robotics floor could not withstand the time with the VPN connection to AWS. AWS has offered some local services, and I'll talk about some of those things like outposts and local zones to try to get some of those companies into the cloud. AWS announces regions, which essentially contain multiple data centers you could think of. So, the first AWS region was US East 1, which is in Northern Virginia. It does consist of six, six availability zones, which essentially are mini data centers, within there. So essentially you can think of it as independent. So, and we'll talk about, how to make high availability or redundancy by using multiple availability zones. As some folks realize, oh, okay, well, I want to just use one. Well, there could be an issue within one availability zone. So essentially, we're looking at connectivity across, and we'll talk about that. But you can see the redundant networks in between. And when it travels from, say, North America over to APAC and EMEA, some of those are all owned by AWS. So the back end is essentially going through AWS's infrastructure. And we'll talk about, getting into their backbone with the AWS Direct Connect, which is an offering. You can actually connect directly into the data center of your choice. I know there's one in Summer Street in Boston that has a data center global connectivity from there is one option. Here's a little bit about the different regions and the number of availability zones. So you can see the top one is GovCloud, which not everyone uses. It did start out with the one US East region, and then US West 2 came on a little bit later. But essentially, majority of the companies and some of the companies that are on here today are probably going to be able to just use the standard regions, because some of the GovCloud regions do not satisfy the requirements for security and government, that some of those services aren't going to be available. So if AWS launches a new service at reInvent, usually it's not ready for GovCloud. It needs to go through validation through FIPS and a few other things. And it normally takes a little bit of time to get that validated, and some of those features aren't available usually in some of those other regions. Okay, so let's talk a little bit. So I did talk a little bit about the region design, but we'll just drill into it. It's shown here on the actual diagram. So it is composed of multiple availability zones for the availability, scalability, and fault tolerance. So applications and data are replicated in real-time consistency in different availability zones. So you think of it as, one of the main services. Not the first one. A lot of people think that S3, the simple storage service, was the first AWS service. It was not. It was another service, SWF, I believe, came out first, but that's just a little known interesting fact about it. So like I said, the regions are interconnected in between, but when you launch we'll talk about launching your own virtual private connect, which is VPC, where you can define your availability zones. If you want multiple availability zones, I know it costs more because there is an egress and ingress cost for transmitting across availability zones. So you might have a development environment, or maybe just one person's environment. You just want to play around a little bit. Usually you can get by with just one availability zone to save costs around that. And then you can see in the availability zones, each of those have discrete power, networking connectivity. So those are housed, you think about, that standard hey, my data center needs to be about 30 miles or more away. Well, this is all taken care of by AWS, and they have a high availability. Usually in between availability zones, it's, there's not a guarantee on the latency, but it's usually between, less than 1 millisecond all the way up to 3, depending on the connectivity in between. Availability zones. So they are isolated from other availability zones. So if there is an issue with one, there usually isn't unless it's actually a global alert. So I know with AWS, there's events. So there might be issues with services or whatever that they post about the health, AWS health. So usually it's not going to be a global region. So it might be a data center. It might be exclusive to maybe your account. So if you've deployed within 1 or 2 availability zones, one of those might be affected in that data center that's having the issue. And you can see there's East 1, 2, A, B, and C. So each of them, the different regions have that classification. So one of the other regions that come to mind is there's US East 2, which is essentially in Ohio. So that would also contain 3. Interesting, where US East 1 has a total of 6 availability zones. It's because it was the first, I call it grand old first region. So there might be some extra regions there as they retire and then move over to some new data centers while they update some of the infrastructure on AWS's side. Here's a showing availability zones. So you can see the AWS backbones between the transit centers, the ISPs, the fiber that's connectivity, and then also the public, diverse tier 1 providers. So when you have an internet gateway that's listed, you can tell that when you're going out, AWS handles that. So when in your account, we'll talk about that a little bit later. I think closer towards probably demo 3, I believe, we talk about internet gateways or demo basically the lab 2. Okay, so let's go to the next slide. So again, it's availability zones and VPC sliders. You can see in this has been defined as 10.10.00/16. There are default VPCs in each region that are there, unless maybe administrator or another person that's gets rid of the default. So the default is 172.31.0.0/16. And that's provided in each of those regions. You don't need to use that. It's just there for people to get easy access, but essentially you want to define your VPC depending on how you want to at the top level. So within that VPC, you can break it down into various subnets, and we'll talk about the private subnet, which isn't exposed to the internet, but it might want to be able to get outbound to the internet, or maybe they don't want to get outbound to the internet. And then there's a public, which will allow ingress from the internet, and we'll talk around some of those things later. Okay, so let's go back into the VPC. So, it is a logical isolated section of AWS Cloud where you can launch AWS resources. So it contains IP addresses, subnets, your routing rules, security rules, network topology. So you basically can define your own VPC, and you'll see that in an upcoming lab. And then here's some of the various services that are in there that require the VPC. So you can see EC2, Elastic Cloud Computing, which are basically virtual machines from various flavors of Windows and also Linux. Lambda, which is serverless, is very popular. Those actually require VPC networking to run in the environment, even though it is serverless. And then you have Amazon RDS, which is its relational database service, which has various database flavors from Oracle, Microsoft SQL, MariaDB, or just a few to mention. Amazon Redshift is a data warehouse. And then on the right-hand side, we'll talk a little bit about, in one of the labs or later, we'll talk about endpoints that are kind of global services that aren't in your VPC. So DynamoDB is a global service, and S3 is the same. And then here, like earlier, you said the earlier shown that the 10.0.0.0/16 And then you can define in each of those availability zones, if you choose to have 2 or 3, usually 2 at a minimum. I usually recommend maybe 3, especially if you're running a production level application, just because there are times when I've seen the availability zones go down in multiple locations, not to just mention the region itself. So those are, kind of things to consider when you're looking for that. So this just kind of goes over the constructs of building the VPC, the various regions. In this case, we're just talking about US East 1, A, and B, the public and the private subnet, which I mentioned earlier. Those are different components that you might want to use. And then this just kind of just shows you, hey, this is, the flow of, AWS's region, the availability zone, and then the data center, the rack host underneath. So you have the ability to choose your, for example, your EC2 instance sizes. So, there's ones down to, 1 CPU, 2 gigs of memory, all the way up to full bare metal, where you own, you purchased and basically own that physical server in AWS's rack to run, some of your things. I know like Microsoft licensing is one of the things that was required. Also VMware on cloud on AWS, essentially VMware buys physical servers to run the VMware cloud on AWS and then offer it to the consumer. And then this is just kind of a little bit about, what those IP address. So you define the subnets, but that doesn't mean you get the entire grouping of addresses. So, the 10.0.0.2, that first address, no matter how you define your subnets, is going to be taken by the Route 53 resolver. So that's the DNS provider within AWS, and that's actually private and then also public. You do have the option to forward those requests from there over to, say, if you have connectivity to a data center or want to run your own within, say, Active Directory. So those are options for specific domains too. And you can see the VPC router, and then 3 and 4 is reserved for AWS. So you don't get essentially the entire block of 254 addresses. So there's a few that are carved out from AWS that are used specifically for AWS's purposes for redundancy, and then just providing those services underneath. And then, IPv6 addressing. There are companies that are starting to use more and more. So a while back, IPv6, probably 4 or 5 years ago, there was a beta service. Had a number of companies that I worked with that needed that because they had an iPhone application, and the iPhone required to have IPv6, functioning on the iPhone for gaming. So they were allowing public inbound, but not behind the scenes. Didn't really matter around private addressing, but the AWS did start charging for public IP addresses just because of the lack of public IP addresses in the IPv4 space. And then also trying to get some more folks to migrate over to IPv6 for those environments. This is a relatively new service, probably about a year or two. It's a IPAM, because it was hard originally. We had a lot of requests when I was working at AWS around, hey, can I use my own IPAM solution to kind of keep track of, the VPCs, how many IP addresses are used. So essentially you could come up with your own script to kind of determine and query. But a lot of companies wanted to use, have a monitoring in a single dashboard to provide capacity planning and alerting of overlapping sliders, because I know Lambda, if you don't terminate some of those functions, those IP addresses are used up quite fast by ENIs, which are elastic network interfaces, which take out of your subnet pool. So those, will soon exhaust. So then when folks are looking to run an application within the specific subnet or availability zone, there's no IP addresses to be used. So this does work for IPv4 and 6. There is a cost for that, but it is a nice feature to have, especially if you're trying to track IP addresses across a lot of multiple AWS accounts or across multiple regions in your environment. And then this is just, subnets and route tables around defining how to route your traffic. So like I said earlier, we'll get into it, is there's an internet gateway, virtual private gateways. Say you don't want to have internet gateway, but you want to route all your traffic maybe back through your data center, or establish connectivity as, the primary means to get to your data center or even your office, or provide like a backup connectivity option. So if you do have a direct connect, you might want to have at least a backup. Sometimes some folks don't want to pay for two direct connects that are redundant from two different providers, two different locations. So they use a direct connect, and then the backup connection is a virtual private gateway that goes back into that location. VPC endpoints, direct connect, VPC peering, and then we'll get into the relatively newer one, is transit gateway. And then, like I said earlier, the internet gateway is horizontally scaled, redundant, available. So basically, when you define your internet gateway, it is one IP address, but AWS takes care of, failure, routing over, or if it's available. So it doesn't really matter. You don't need to define that. If you do have a NAT gateway, that's where, depends on if you want to use their NAT gateway service or launch your own. That's where, you don't have to worry about outbound internet access. And then how does my instance get an IP address? Elastic IP, this is an IP address that is publicly available. So this is the one I told you that they started charging like 0.001 cent per public IP address, I believe. I can get accurate costing on that, but I was a little surprised, but I get it. Just because of the exhaustion of all those the IP address, IPv4 space. Can be associated with an instance or network interface, remap to another instance in your account. So say if you had some kind of application that you're running that had, a public endpoint that you were using for, maybe sharing out and only allowing access to that IP address, and say that instance went down or you wanted to fail over, you could use that elastic IP address as the point to get in for various AWS services. And then the outbound only internet access. So I talked about the NAT gateway. There is a NAT gateway service from AWS. They manage the so they scale up and scale down. So when you have a NAT gateway, so they'll launch, it's fully managed by AWS. It's 5 gig of bandwidth. It scales up to 45 gig. So if you don't use the traffic, it will scale up and scale down. But when you do want to burst and use a lot of the traffic, it actually will add some more functionality. Essentially, basically it runs an EC2 instance that AWS manages in the background. So they'll scale that one up from like a T series up to maybe like an M5 or something like that, which is a larger instance that can handle more traffic if it need be. This just shows you the tables around intra VPC routing and how traffic flows. So, you can see that, do you want to propagate your routes automatically, in those availability zones, or do you want to actually not run? So you can define static local routes, or we'll talk a little later in our presentation, we'll talk around the border gateway protocol, which is BGP, where you can use BGP in your environment to automatically update routes through your AWS infrastructure. And then this shows you another diagram where, I want to route some traffic over the target host, over the ENI, which is the elastic network interface. Does it propagate? Then you also see some of the routes that are IPv6, and those routing tables are controlled by you depending on how you set your VPCs up. And then this is just networking at the instance level. So like I said earlier, the EC2, the virtual machine, there's a service called the instance metadata service, which provides metadata around each of the EC2s that are being run. So you can query the Amazon time sync service. So you'll see everything's a 1969254 address. So you can actually get this information directly from the host. But that information is not going to be publicly available. It will be, available if you want to get some of that metadata information from the host itself, this is a functionality that you can see that is working at the IMDS level. And then this is the last section that kind of briefly touching upon VPC sharing connectivity before we get into the first lab. So can I have one account owning the VPC and the other one using it? So yeah, you can share VPCs across, the owner can create and edit VPC components. VPC participants can launch resources in their assigned subnets. And then there's a service called AWS Resource Access Manager, which is RAM for short, under AWS organizations. That's another probably seminar or workshop more around security. Start off with the IAM and then probably get into organizations and some of that at some point later on this year. So basically just shows you that this is how you can share. This is one of the first ways of doing it a while back. But now there's a lot of other ways. So you can VPC peering, directly connecting to other VPCs. This is highly available, scalable, inter-account, same different regions. So you could peer across regions. So say if I wanted US in the East Coast, US East 1, all the way out to Oregon, which is US West 2, you can peer those accounts and basically it's bi-directional traffic. You can have security groups that are referenced for the same region VPC peers. So you can we'll touch upon security groups and NACLs, which are network access control lists, and the differences, but you can assign which ports, TCP, ICMP, UDP. It does not do transitive routing, so it does need a full mesh to interconnect multiple VPCs, and you can't have overlapping IP addresses. So if you do have IP addresses that are the same on the other side, that's not possible to route with the VPC peering. And then this is the newer service that's come out probably in the last couple of years to try to push using the AWS Transit Gateway. Allows you to connect thousands of VPCs across accounts, does on-premise through a single gateway. It centralizes the VPN and direct connections. They're trying to make it easier for companies rather than having separate ones. And I wouldn't say I hate this term single pane of glass, but it's essentially one point. You can allow maybe if you have segmentation in your groups around what can be done, this could be offloaded to the networking team and they can kind of use transit gateway service and some of those functions just to do that. So, when you're first getting into AWS, you want to make sure. So a lot of times some companies are looking to migrate. Depends on what they want to do. They want to migrate, you want to create a brand new environment, but essentially you want to have some kind of connectivity to your AWS environment. Some companies are restrictions about, I don't want to access it from, the public internet, but, so this way you provide some kind of connectivity measure using direct connect, and we'll talk about VPN and some other methods to connect from data centers or even the office space. So you want to make sure it's distributed network architecture, it's available, resilient, and then also a little bit about recovery planning. So these three different options, the AWS Transit Gateway, the Direct Connect, and then the site-to-site VPN are some of the options, whether it's the primary, secondary, backup. These are the various methods to use. So the site-to-site VPN, essentially within AWS, once you've established your VPC, which we talked about in the beginning, and then you did today in your lab, is you define a virtual private gateway. With that virtual private gateway, then back to your customer gateway, and this is on your on-premise network. So when you go through the creating your virtual private gateway, you can define, the vendor. So from Palo Alto, Checkpoint, Cisco, could be also a generic, VPN configuration that you can use, so to use some kind of open source, but essentially provide you the configuration to set up the virtual private gateway connection to AWS. And, some folks decide to use the redundancy that's built in. So when you create that configuration file, it actually gives you two endpoints on AWS's side. So if one of those goes down, the connectivity will be established to the other one as the primary. The only downfall, and we'll talk about it later, is the amount of bandwidth that's capable with the VPN. It's only about 1.25 gig. So you might not even have that as your pipe from your internet, but you probably do nowadays. But essentially it cannot be grow over that. So that's why the next one that we're going to be talking about is, possibly a site-to-site VPN, but also going into the direct connect side of things. So you can see the site-to-site VPN with the transit gateway has the ability to establish connectivity to multiple, VPCs. You can define that with the transit gateway, manage all those connections in. Like I said, the customer gateway, the VPN connection, and then these could also just be transit gateway connections via direct connect and not using VPN. So you might have on-premises network that uses one option. So basically that's how that actually works with the transit gateway side of things with the site-to-site VPN. Let's go on to the private network. How do you connect over the internet? So like I said, you create the virtual gateway, private gateway per VPC. It's a redundant IPsec VPN tunnels terminating different availability zones. So if there is an issue in one of those availability zones, you still have connectivity into the other one. It does use AES 256-bit encryption, SHA-2 hashing. Like I said, it is scalable, but it has the issue around the amount of bandwidth. There is BGP or static routing depending on your customer gateway. If you have the ability to do BGP with your firewalls routing or your endpoint, most vendors do nowadays, but you can still use the static routing option. This is up here. This is not for data center connectivity, but there is a fully managed VPN connectivity option. So if you don't have, you want to kind of control access to maybe your AWS account if you're just getting started, looking at establishing a direct connect or figuring out your customer gateways, there is an option to only allow access to AWS environment via the AWS client VPN. Again, this is a managed service, fully managed and secure TLS connections from any location using OpenVPN. So, so OpenVPN managed instance by AWS. They managed it. It does support split tunneling, so you don't have to route everything through, only certain DNS. So if you want to get to the environment for that specific network CIDR addresses, then you can just route that. But if you want to let the folks go outbound to the internet or other areas, it doesn't need to flow directly over AWS. Again, and also it uses authentication with Active Directory if you want to connect Active Directory in there, federated authentication, or traditional certificate-based authentication. So each individual user gets their own certificate to connect to that environment. And then now we're going to talk about the AWS Direct Connect. So the Direct Connect is probably the best method, especially if you're looking at, doing a full AWS migration. So then that way you're not flooding the pipe. So if you are looking for replication or basically copying a bunch of data from your data center over to AWS, whether it be backups or whatever, you're not going to flood your traditional internet pipe. So this is going to go directly over the Direct Connect via the transit gateway, the Direct Connect gateway. It does, we'll talk about the various types. There's a dedicated direct one. There's also one that you can get through a partner that maybe you don't want the full gig all the way up to 10 gig. If you want something a little bit before 1 gig, there is a partner availability option on that. So the hosted versus dedicated, like I said, the dedicated ones are 1 gig, 10 gig, and 100 gig. Does allow virtual interfaces. So the virtual interface is how you want to actually route some of your traffic and make it publicly or public. So private VIF and a public VIF. So the private VIF is only established via BGP autonomous system number. So you'll broadcast that number, but it's only for private routing. The public VIF is if you want to have a public VIF or establishing connectivity to those global or public AWS services over that. So that's a little bit about the actual dedicated instance. So one of the first direct connects I ever had was a hosted. Didn't want the 1 gig fully. We were trying to experiment. We should probably went with the 1 gig, but we were able to get it hosted for about 100 meg up and down. That was, fully basically overused initially, but essentially we're able to use that from the actual partner managed router side of things rather than having our own customer managed router. Say if you don't have a networking team that kind of manage that. The types of virtual interfaces. So you saw earlier in that other diagram, it said the private and then the public VIF. So you can see the private VIF is the direct connect gateways that are defined, to the number of VPCs, how that is routed. The direct connect gateway, you can have, 3 times transit gateways. So essentially it's a VLAN plus a external BGP session, IPv6 and IPv4, peering sessions supported in all the above virtual interfaces. And then to the right, when it said public VIF, so these are the public types of services that you'll route over to Direct Connect. So you'll advertise the routes to say S3, CloudWatch, all these other services which are public available on AWS. It will go over that Direct Connect, not over the public internet, but this way you can advertise those various routes for the private transit and also the public. The Direct Connect is a dedicated network connection from on-premise to AWS. It's the various sizes from 1 to 10. You can have multiple VIFs. You could also have various network performance. So if you want to actually channel those, you can actually also use multiples for that for the same location if you wanted to. But you can connect to 90 plus direct connect locations across the globe. So one of our partners, Equinix, they're like one of the first providers for direct connects, has locations in New York, Virginia, Chicago, all over. There's a number of other different providers that also provide the direct connects or some of the managed direct connects if you want. And then how to add redundancy to the direct connect circuits is basically you want to make sure that you can be deployed with multiple or single circuits and providers. So what I've done when I first we had that managed. So what we did was we added another one from another provider, but we also had it going into New York City rather than Northern Virginia. So we did have some redundancy just in case the location or had an issue with one of those data centers. So we were able to route depending on the location. Most of our services were in US East 1, but we did have that different gateway just in case there was a problem with, say, one of the actual external providers if they had an issue. Okay, so how do you access it? So like I said, the VIF, there's the private VIFs, the public VIFs. So this shows a diagram of what kind of services. So you can see from the diagram, the public VIF, there's the S3 bucket. So all the traffic would go over there based on what you're advertising for that. And then you have your 2 VPCs that you created in your AWS account with a virtual private gateway. So those are using a VPN connectivity through that. And then basically the direct connect is having the direct connection to the location with the customer gateway. So that kind of shows you a little bit the basic connectivity options with Direct Connect. Next, we're going to briefly touch upon Amazon Route 53 resolvers. So I know earlier when we were talking about the subnets and you saw that .2 in your basically whatever you chose how to slice up your network was dedicated to Route 53 resolver for the VPC. So you can see Amazon provided DNS. So basically it resolves instances within your, so when you launch an EC2 instance within your environment, it'll have that specific name. So you can see up here, it's got the IP That's actually, the reverse lookup for that name. And then also you can see EC2, and then there's another one for each of those instance types. But those are how it knows and how to route in your environment through that interface. And you can see the host names, the private DNS, the resource-based private DNS name, and the public DNS name. So you can define those, and you need to enable the DNS host names are enabled and resolution enabled if you want the functionality. You don't have to have that, but it doesn't need to be your primary. So it is nice to have, just because it will be able to talk AWS services or resources in between. But if you do have your own domain, you can provide the DNS through also Route 53 by defining your zones, and we'll talk about that. And I think that's actually going to be in the next lab. So you can see the Route 53 private hosted zones. So for this example, there's an example that AWS, there's a DNS record that you create for those VPCs, so it knows how to reach those instances, application instances, or the database instance, which can be an RDS instance. Route 53 resolver endpoints. So this is fairly new with the endpoint services. So there is endpoints that you can actually define for inbound and outbound. So it allows you to say, hey, I want to have resolver rules for outbound for my VPC to say you have a direct connect or a VPN connection back to your data center, but you want to resolve those, domains back across, so you can actually set a rule to forward across to for the other DNS servers that you have nearby, whether it be traditional bind servers or Microsoft's Active Directory integrated DNS. And that just shows you how it happens. So then the inbound endpoint, that's a mouthful. Essentially will do the same. So essentially you can say in those data centers, I'm going to forward those over to the Route 53 resolver, so that endpoint will be able to resolve. So individuals or machines that are trying to connect from the data center network can resolve properly based on this resolver for the endpoint inbound. The next section is, okay, great, you have connectivity between the various data centers, but then it's like, okay, well then how do I monitor this? It's not your typical data center. So folks, getting into the cloud, it was confusing for myself to try to see all this information. So this next section goes over various tools within AWS that you possibly, you can try to use some of your tools in your typical data center or your typical approach. Some of them do work, but the ones on AWS are cloud specific. You don't have to use theirs. There's tons of solutions. We partner with Dynatrace for application monitoring and network monitoring, but we're just going to touch upon the native services within AWS to get you started. So let's go ahead and, okay, what are the foundational observability? So, you have metrics that are defined by business units, KPIs, availability, what's my service level agreements or SLA, what's my service level SLOs, because within AWS, they do define SLOs for AWS support responses to tickets rather than SLAs. So there's usually a distinction around that. So there are a number of different logs from various services. So how do you aggregate those or take a look at those and trace those back, for connectivity reasons, and try to grab some of those metrics. So we're going to touch upon, the nature of the logging within observability. So you can see from operational all the way to business. So you want to track that transaction. So once you get towards the business side, again, it's more around the application performance monitoring. Is the application performing well for my customers or my end users? This could be internal customers, it could be external application for your company. So you definitely want to have that visibility end to end. So the first one is built around infrastructure monitoring. So this is CloudWatch metrics. So this automatically collects default metrics from more than 70 AWS services. You can define what kind of metrics you're looking for within there, but there is the ability to kind of drill down into those and create various alarms. So in this next lab, you'll go about creating a CloudWatch metric and kind of alarm the set a threshold on metrics and trigger an action. So you could trigger an alert being sent out by simple notification service. You can do SMS messages for your traditional. A lot of folks nowadays, and it's very valuable, is to kind of take an automation approach. So if you're getting triggered on a various event, you can trigger maybe AWS Lambda function to operate to kind of help with automation, or typically with a CloudWatch alarm, if you have, and we're not going to be talking about this, but it's an auto scaling group that will automatically scale based on, say, CPU usage of your instances, or basically memory. It will scale upon that action. So CloudWatch is basically provides the capability for monitoring all your AWS resources. It collects the metrics, logs, and events. It's published by AWS. And again, most of the new services or any services within AWS has CloudWatch metrics. You can also customize your metrics from your own applications. So you can ship CloudWatch logs or just logs over to CloudWatch and create a metric once it ingests into that system. And then it shows you tracks the usage of some AWS resources and service quotas. So AWS, what does that mean? So service quotas means that AWS does have service limits. So they kind of put guardrails on various services so you can get the usage on those. So let's go ahead and CloudWatch alarms. So this is so in this next lab, we'll go around creating the metrics alarm. So there's various types around composite alarms and anomaly detection alarms, past metric data, and creating a machine learning model based on the expected values that you might see within maybe your workload. So a typical time frame, maybe during 1 o'clock to 2 o'clock, there's a rampant maybe some kind of job that runs that's typical, but anything outside maybe that specific window is an anomaly. So it will actually detect that, determine whether it's a nefarious activity, maybe malicious, or something else, or just one of those things that normally doesn't occur just because maybe the job got launched later due to an error or a time frame. And then you can see down below, so you see the available actions that I talked about earlier. So the simple notification SNS, you have auto EC2, Elastic Cloud Computing, auto scaling action. And then you have ops items for incidents in AWS Systems Manager. So within Systems Manager, you can create incidents or items to track within your AWS environment. So this is a rudimentary kind of just a low level monitoring key metrics with CloudWatch. You can see these are the various metrics that are there. This is just in a sample graph that's being shown, basically just kind of connections by second ingress. You can also see, various other things. So these metrics are available. You can choose to create custom dashboards, and you can also publish these dashboards for maybe certain individuals within your company to maybe look at certain things, or they don't want to drill into that, so that you can provide these metrics maybe to similar to like a NOC or a support group. Traffic visibility and monitoring. So this one's key. I know every time when a lot of folks within AWS says, well, how do I mirror? So this was not available for the longest time with traffic mirroring. So, a lot of folks were running, I for one was running, mirroring traffic and running a network intrusion prevention and network IDS system, and you didn't have the capability to tend to take a look at that on AWS. Well, several years ago, they launched traffic mirroring, so you can actually set up traffic mirroring on an Elastic network interface and basically collect that and duplicate that traffic and kind of choose to do with it. So a lot of companies have developed products third party, but you can just use native AWS around copying and collecting that data. Amazon VPC flow logs. So this is not enabled by default, but if you do enable this, the flow logs there's a lot of them. So it's ideal if you want to know what you're looking for. So when you first create this, you want to make sure that what am I looking for? Am I looking for content inspection, threat monitoring? Am I just looking for basic troubleshooting? But if you do collect and store the header information, it does show the source, destination IP addresses, and the packets, but it does add up after a while. So if you do collect everything, you might want to purge it or only keep it for a certain amount of time or send it off to S3. So basically making sure that you want to know, because this will end up adding up in the long run. VPC monitor. So you can see this is just showing you there's no traffic mirror sessions found. You don't have any going. You can create a traffic mirror sessions. So from the internet gateway, you can actually have EC2 instances to analyze the traffic, open source traffic analysis. And then, like I said, there's traffic mirroring partners that actually have software that operate to perform the various functions within security or just network traffic, and that analyzes within your AWS environment. Now we're going to touch upon, security controls within AWS, and we'll talk about network at ACLs or NACLs, and security groups, and then VPC endpoints. And the next lab will actually go about creating those different things. So let's go ahead and get started. Can I filter the traffic reaching? Can I actually go too far here? Nope. Can I filter the traffic reaching my instances? So security groups, it's a virtual stateful firewall that's set aside for the various inbound and outbound customer defined rules. So it's at the instance interface level inspection. All instances have at least one associated security group. So by default, it does not allow any inbound connections. It does allow outbound connections. Can be cross-referenced. So if you have, multiple VPCs peering in inter-regional, you can actually mimic those ACLs. So say if you have a set of web servers and specific ports that you wanted, you can actually just make those, groups across and then reference those. And it only supports allow rules, implicit denies all traffic. So, by default, if it's not allowed, it's going to deny anything that's not defined in that stateful firewall rule. So let's take a look at security groups, about, some of them on this slide. So you can see an example that we have. We're allowing inbound TCP traffic on 443 for HTTPS for users. In that security group, you can see, it also is defined for IPv6, and then the source is going to be the security group 00C3, which is essentially any kind of web server that's defined in that security group. And then you can take a look at the next one is actually, so if you want to segment out your traffic to your typical 3-tier, you have the web traffic coming to that one group, but then the only allowing the security group from the web servers to contact the database layer. So in this case, it's MySQL or Aurora, which essentially is just Aurora MySQL managed instance with high availability and some other features from AWS. So you can actually get that, shows you how the finely granular control traffic with stateful firewall rules. And then it says, can I filter on a subnet level? So say if you don't want to let some traffic, what's going to be coming in, you filter it out at the network level. So this is basically, not stateful, so it's stateless. And, the best way to track these is VPC flow logs to try to determine, because sometimes I've seen customers actually, blocking traffic with flow, basically network access control list, not seeing where it's coming from and being logged, and then essentially just like figuring out like, well, what did I do? Was I too hard on those rules? So essentially what you have is inbound and outbound subnet. So if a certain level of traffic is incoming, so you want to just define it that way, so you don't want any garbage traffic coming into your subnet, you can define those rules. And again, it's got the implicit deny by default. And let's take a look at a couple of those different rules so you can see the source port. destination port. So basically you're saying, okay, in this case, I'm just going to allow all inbound, regardless of what it is. And then by default, is the rest of it's denied. And then the outbound is also allowed. So this is a little bit, too permissive, but if you want to lock that down, let's take a look at, those NACLs. So in this case, you can see SSH port 22 is allowed via an IP address, and then also an IP address in the IPv6, and everything else is denied. So in this case, they only want, so this looks like almost like a bastion host maybe. That is allowing SSH access. And then you can see in the bottom side of things on this custom list that the port range is only allowing anything above 1024 outbound. So originating any inbound and then outbound traffic for those SSH connections or any other connections on that. Okay, let's go ahead and go to the next slide. Let's go to the internet gateways. So there's 5 things about internet gateways. There's a public IP, security groups allow, NACLs allow, attach internet gateway, and route to the internet gateway. So you can see in this example, the default destination is the internet gateway. Does not need to be the case all the times, but this is for the public subnet. And you can see also the inbound and outbound rules for that too through the internet gateway are defined there. And then this is just showing you the next one that's being touched upon, and it will be shown in the lab as VPC endpoints. So when accessing AWS services without VPC endpoints, you can see the progressive nature of where it's going to go. So in this case, the subnet here is actually going to go outbound to the VPC and then go out the internet gateway to these public AWS services. So it's going to go outbound. So, maybe you don't want to allow an outbound internet traffic. So that's when you can access AWS services with VPC endpoints, which are essentially private links. So you can have that interface endpoint establish a private link going into those AWS public services so that anything within those VPCs are not going out to the internet gateway, but they're able to talk to AWS services, which are in the public domain. And then you can see the next one, the VPC gateway endpoints. So in this case, you have the interface endpoint for private link for those over here, but then these gateway endpoints. So these are the 2 services that say you don't want the S3 going outbound, but you want to establish S3 connectivity for copying, artifacts or something over to S3 or using DynamoDB as a database. So those are the 2 different options you can use with gateway endpoints. So then private link, again, this shows you, the endpoint service. So I found that private link, so you have the consumer VPC and a service provider. So if you're a company that has a software as a service SaaS product, you can offer this link. I know AWS Snowflake is one example where they provide you a private link to connect to their Snowflake with the data warehouse service, which utilizes Redshift, and then they offer some other things on top of that, but it provides an endpoint to get into that and is secure rather than just allowing it publicly outbound to the internet.